So this video is just going through the structure and the function of the heart. So by the end of this video, you should all be able to identify the key components of the heart. Some of you will be able to identify and label key components, and some of you will be able to explain the role of the key components of the heart. So if we just look at heart structure, we went over this in assignment 2 anyway, but we'll just remind ourselves. It's about as big as your fist. So if you make a fist, your heart is about as big as that. And it's located just left of center of your chest. So if you put your fist just left center of your chest, that's roughly the location. That's roughly how big your heart is as well. You should remember from assignment 2, there's 3 layers to the heart wall. So we first of all have the pericardium, that's the outer layer. So I'm not going to talk too much about this, but the role is to reduce friction and maintain the heart shape. Myocardium is the middle layer, it's the largest. It's used in the electrical impulse of the beat of the heart, and it's also like the thick sort of contraction muscle layer of the heart. There's the endocardium, and the role of that is that it prevents friction between the flowing blood and the heart muscle. It's a very inner layer. And you should recognize this slide from when we went through muscle structures, but it's a nice visual example showing the 3 separate layers of heart muscle. Okay, we've got four chambers of the heart, and I'll go through them in a little bit. But first of all, what I need you to know is whenever you look at a diagram of the heart, left is right and right is left. Once you get your head around that, I think it's much easier. So this section here, the blue section, is the right hand side of the heart, excuse me, and the red section here is the right hand side of the heart. So it's just reversed. The reason this is, if you had a handout of the heart in front of you, if you picked it up and put it in front of you, it would actually be the right way. Whenever you see blue, that's always to do with deoxygenated blood. Whenever you see red, that's to do with oxygenated blood. Okay, now we know that, let's go over 4 chambers. Now, this very top chamber here is the first one I'm going to talk about. Your first 2 chambers, they're called, if you talk about them collectively as atria, but individually as an atrium. So this right chamber here is the right atrium. Then these bottom 2 chambers are called ventricles. So that's the right ventricle, left atrium, left ventricle. Now the role of the right atrium is to collect the blood from the body. Once it's collected the blood, that will contract and send the blood down into the right ventricle. Job of the ventricles is to pump blood out of the body. So the right ventricle will contract and pump that blood up to the lungs, get oxygenated. Role of the left atrium is it'll collect the blood from the lungs, the oxygenated blood, and it'll contract and send the blood down into the left ventricle. Role of the left ventricle is to contract and send that blood all around the body. Okay. What I'd like you to do is pause the video now and try and fill in the gaps. Right, now you've paused the video, let's have a little look and see how you've done. So the first sentence is, the right atrium receives deoxygenated blood from the body. It contracts the blood into the right ventricle. The right ventricle contracts and sends the blood to the lungs. The left atrium receives oxygenated blood from the lungs, contracts into the left ventricle. The left ventricle then contracts and sends the blood to the body. So that's just what we talked about then in the previous slide. Right, now we know the different chambers of the heart. We now need to know other structures. So first of all, we've got the wall between the 2 sides. This is known as the septum. It separates the heart from left and right. Now this is really key. The right side of the heart is to do with deoxygenated blood, and the left side is to do with oxygenated. Now, if we don't have that wall there, it's not stopping the blood from mixing. Now, if the blood mixes, it's going to be a really ineffective pump, because if you've got some oxygenated blood going up to the lungs, that's no use to us, because it's going to the lungs to get oxygenated. So if it's already got oxygen, that's a pointless exercise. Consequently, if we got deoxygenated blood on the left hand side and it gets pumped around the body, that's also useless to us, because it cannot give the body the oxygen it needs so it can utilize that as an energy source. So by having this wall here, it's very effective to stop the blood from mixing together. We then got the vena cava, and that is the blood vessel that will bring the blood up to the right atrium. We've got the pulmonary artery. Sorry, just come back to the vena cava. We've got two vena cava. We've got superior and inferior. Superior vena cava is what collects blood from the top half of the body, and inferior from the lower part of the body. Pulmonary artery comes out of the right ventricle. Arteries always carry blood away from the heart. And the role of the pulmonary artery is to take that deoxygenated blood up towards the lungs and get oxygenated. You've then got the aorta. The aorta's job is to take the oxygenated blood to the body. So when the left ventricle contracts, it sends the blood out of the aorta. You've then got the pulmonary vein. The role of pulmonary vein is to return the oxygenated blood from the lungs down to the left atrium. And this is just basically what I just talked over. But once you've downloaded the PowerPoint, feel free to read through that. Right, there are 4 valves in the heart that you need to know. Now, the role of a valve is to stop backflow of blood. So basically, what I want you to imagine now is that the blood has gone from the right atrium down to the right ventricle. Now, a valve will open one way only and shut the other. Now, this is really important for us because when the right ventricle then contracts and that blood up to the lungs, if the valve wasn't there between the atrium and the ventricle, it could just send blood back to the atrium. Again, that's a pointless exercise. We don't want to do that. We want our blood going specifically either to the lungs or to the body. Now, if it goes back to the atrium, we're not sending as much blood to the lungs, therefore it's not getting oxygenated. That is why we need the valves there, to keep blood going in that one direction. There's 4 valves in the heart. First one we're going to talk about is the bicuspid valve, which is also known as the mitral valve. Make sure you know the difference between the two. Not the difference, make sure you know the similarities and the same name, sorry. Because when you sit your YMCA exam, they will change terminology, and it might confuse you if you don't know both terms. So it's found between the left ventricle and the left atrium. Prevents backflow of blood from the left ventricle to the left atrium. So similar to the example I just said. And like I said, it's also known as the mitral valve. Tricuspid valve is found between the right ventricle and right atrium. Has the same role as the bicuspid valve, but obviously just on the right hand side of the heart. Then got the aortic valve, which is actually found in the aorta. And that just stops the backflow of blood from the aorta going back into the left ventricle. Then you've got the pulmonary or semilunar valve, and all that does the same role as the aortic valve, except it's for the right side of the heart. Whenever you see this term pulmonary by here, always think lungs. It means something to do with the lungs. So you'll automatically know the pulmonary artery and pulmonary vein has to be going or coming from the lungs. It's got the word pulmonary in it. Okay, a nice saying I like to use to remember the order. When you go shopping and you want to buy clothes, you try before you buy clothes. So you try before you buy. So that is how you can remember the difference between the tricuspid and the bicuspid valves. The tricuspid is on the right side of the heart, you try before you buy. So if you see the right atrium and right ventricle here, the valve's just in here. Bicuspid valve is exactly the same except it's on the left side of the heart. So left atrium, left ventricle, so bicuspid is there. Then you'll see these valves in the pulmonary artery, and you'll see it in the aorta. So the aortic valve is just here, and it stops the blood going back through there. And the pulmonary valve or semilunar valve is just here, and it stops the blood going back down to the right ventricle. If you click on the picture once you've downloaded the slides, it'll take you straight to the purpose game, so you can practice labeling the heart, so you know, demonstrate you know all the structures. This diagram just shows all the structures in one. Okay, the really key, you know this, blood flow through the heart. So we talked about this briefly earlier, but I'll talk about it now. So we're going to start at this point here. So blood will go up the vena cava. So don't forget, we've got the superior, which is the top half of the body, and inferior, lower part of the body. So deoxygenated blood comes here. It will then come to the right atrium. The right atrium will then contract and push blood into the right ventricle. It will go through the tricuspid valve, which is by here. The job of the tricuspid valve is to stop that blood going back through to the right atrium once the right ventricle contracts. Right ventricle contracts, sending blood up the pulmonary artery. This here is your pulmonary valve or your semilunar valve, and blood will go up the pulmonary artery to the lungs here. Lungs oxygenates the blood, and it then needs to return blood back to the heart, so it goes down the pulmonary vein. Pulmonary vein then goes into the left atrium. Left atrium will then contract, sending blood down to the left ventricle, going through the bicuspid valve. Again, same rule as the tricuspid, except on the left side of the heart. Left ventricle then contracts, pushing blood through the aorta, with the aortic valve here stopping going back. Blood goes to the body, exchange oxygen, carbon dioxide, and process starts again. We just go back to this side and see here, this wall is much, much thicker than this wall here. Now the left side of the heart has to be stronger. If you think about it, the right side of the heart is only sending blood to the lungs, which isn't very far from the heart at all, so it doesn't have to be as strong contraction. The left side of the heart is sending it to the rest of the body. It has to be a much more powerful contraction to get that blood up to the relevant pressure to get around the body. Therefore, naturally, because that muscle is working harder, the left side of the heart is thicker. If you click on this video and you download the slides, it'll take you to a YouTube video which will talk through the way blood flows through the heart. Two key terminologies you need to know. We've got pulmonary circulation. Now, the word pulmonary, as I said earlier, you've got to think lungs. Pulmonary circulation is just this bit here. It's between the lungs and the heart. Systemic circulation then goes around, think of your body as a system. So it goes between your heart and your body. So it's then this lower part here. Click on these images here. They will take you to music videos talking about the heart. It's just a nice, easy visual way to learn. Here is my Quizlet here. Use this, practice your tests, your scatter game, gravity game. This will help you get you familiar to the definitions of the key terminologies.